In the last lesson, we saw about various machine learning techniques, and then we saw about the various kinds of metrics which are used for performance evaluation of various machine learning techniques. And now we are going to see, as a continuation of those concepts, these are like some case studies on how various machine learning techniques works and how we can implement them using Jupyter Notebook. And then we have like some tutorials on how to visualize data using Matplotlib library. So when I teach about various machine learning techniques implementation using Jupyter Notebook, we have the usage of Matplotlib as well. But we will have a specialized approach on how we can use them more in detail. Now, firstly, we will see about unsupervised learning, that is clustering. So in clustering, I am showing you about uh, Jupyter Notebook, which I have created, and then we have like the packages we need to import. So these are the packages we need to import. Matplotlib, and so in that Matplotlib, we have to import pyplot, and then we have to import Seaborn for just to give some styles for the plot we get from this library, and then NumPy library, that is the usual one we use for the numerical analysis. And then we import a very important one. We use sklearn. What does this sklearn means? It means scikit. So it is abbreviated in the form of sklearn, and this will have many machine learning techniques, data sets, and so many things available. So it's a kind of quite a cool one to use for machine learning and data science based techniques. So now we are using scikit-learn. From that scikit-learn, we use data sets. From the data sets, we use a sample generator to make blobs. So then we have like x and y as values, and then make blobs. That is n underscore samples is the number of samples we create. We say there is 300 samples, and then we need to form as 4 clusters. Then we have like various performance measures like cluster std and random state as parameters, and then we visualize this data in the form of scatter plot. So we use plt is what we mention here, like this library package matplotlib.pyplot is mentioned as plt. So we can use this plt anywhere else. We don't need to mention the whole package again. So here we use plt.scatter of x of colon comma 0 and x of colon comma 1. So here we have like x of 0 and x of 1. So we have the blobs, so they are all taken into here. So s is equal to 50. So then we have this data generator. So let me show this tutorial by clearing all the outputs. So I don't have the output now, so I just execute this code. So it will definitely take some time for the library function to execute, and then we have like this creation of this data points. So the creation of data points in the case of clustering mentions that we need to manually mention the number of centers we need to create. That is, how many clusters we need to create, it depends on the users. So that kind of aspect is available with the unsupervised learning. Now the learning has completed, so we can see like this circle is white here, the kernel is idle. Then we execute the creation of this blob, and now we can see here the kernel is mentioned as kernel busy. So over here in the left top, the right top corner, so it mentions as the kernel is busy, so it is running, so it is creating the blobs now. So when it creates the blobs, we are not feeding our own data, it is creating its own data, and then it gives this graph like in the form of blobs. It is a scatter plot. Next, we need to fit all these points into 4 clusters, because we have already mentioned as the number of centers is 4, so the number of clusters is 4. So we need to use k-means clustering. So with the help of k-means, we are fitting this. So for that, from scikit, we need to import scikit.cluster. We need to import k-means from there. So then we mentioned that from scikit-learn.cluster, import k-means. This is what we have imported, and then we use this k-means function using number of clusters equal to 4, and then using k-means we use to create a fit. So this will fit into the clusters, and then it has to create the clusters, and then we form the scatter plot based on the clusters formed. Like we have created 4 clusters, so we need to visualize those 4 clusters. So we mentioned like plot.scatter. So the variable x we have already got, and then c is equal to y k-means, and then s is equal to 50, c map equal to viridis. That is the parameter we mentioned for the heat map, or like what kind of color coding we need to use. So that is mentioned, and then centers equal to k-means dot cluster underscore centers. That's what we get as 4, and then we create a scatter plot for that. So here, this scatter plot centers, it will actually place the center of all the clusters. So here we have like 4 clusters, like a dark blue, and then a dark green, yellow, and purple. So then within all these clusters, we have a cluster center. So this cluster center is created using this scatter, plt.scatter of centers. Plt.scatter of x will give all the data points. Plt.scatter of centers will point the location of center of each cluster. Then we use this code like to assign the label, and then we need to create the clusters. So this will show how the clusters are formed, and then we mentioned that to find the cluster. So if we keep changing the parameters within the code, it will give different paradigms, and we can view like whatever way we need to see the data. So it's up to us. And then this is another way. So that will show like how much data are available, and how much dimensions of that data are available, that is displayed. And then we form the number of clusters as 10, and then we create like this is actually a tutorial for MNIST dataset. Previously we saw about the blob, that is a randomly generated data, but here we are having a numerical handwritten database. So we are loading the digits, and then we have like 1797 data with 64 features, and then we use k-means clustering because there are 10 numbers or 10 classes. So if we use clusters, we need to have 10 clusters, and then we display all those sample data, and then we use one particular library newly in this one, that is SciPy. SciPy is normally used for scientific Python, So that is it. It's used for calculating high-level matrix level mathematics. And then we import mode, and then we use to process those images, and then here we import the accuracy score from the scikit-learn. So that is going to give the accuracy value. So by using this clustering we get like 0.7935, that is 79.4 percentage accuracy for this number database. And then we can create even a confusion matrix. In the performance metrics lesson, I have mentioned about how the confusion matrix is created, and it can be done for both supervised and unsupervised learning. But nowadays, predominantly confusion matrix is used for only to mostly to uh, supervised learning, and then we use this for unsupervised learning. Then we get a confusion matrix like this, that is the total number of instances correctly classified or given in this varied number of output. Like here we have like the 0, how many instances classified as 0, that is 177, that is correctly classified. 1 is classified 55 instances, 2 is classified 148, 3 has 154, 4 has 164, and likewise if you just uh, watch on those values which are given in the diagonal matrix, then that is the actual correctly classified matrix instances, that is the count for that. So we map them, the predicted value against the true label value, and then we use this to find the accuracy, and finally we create this to form a clustering of the number of centers we mention, and then we get the output as such we need. So that's all about the demonstration of clustering, that is k-means clustering in Python using Jupyter Notebook. So there are so many other methods coming on. So next we will see about another machine learning techniques implementation using Python Jupyter Notebook.